So these objects, they become self-aware because you define them. You're an X-ray. So when the X-ray is taken, it knows who took it. That's traditional software, because today you could do that. If you take an X-ray, you have a field for the person, the name of the person who took the X-ray, or who the patient is, or what type of X-ray it is. These are all the traditional structured data that define that object. And what we've added is we've added more layers to that object. Like, here's how you capture and maintain your information, Mr. X-ray. These are channels that you have privately for exchanging information or keeping information between yourself and the doctor and the nurse. And here's one channel that is the way you hold communication information between the medical people and the patient. So this is part of that architecture. And by the way, here's your LLM. And the way you interact with these users, you use natural language to interact with them. And the way you humans load documents or attachments, read all of them. Or if you hold there's a conference call that's happening between two people, you are responsible for organizing that conference. And just like we are talking, that object would be sitting there. And at the end, this video file, we don't have to save it somewhere. The object itself will hold it, because the object has a place in the database. And it belongs to that object. And because it can transcribe this video, it'll turn it into text, and it can use the LLM to read it and understand exactly what was said in the conversation. And because it knows what it is, it knows that it's an X-ray, it's a chest X-ray, it belongs to me. It can use the AI aspect of that technology that is embedded in it to read the transcript and understand and remember what it said about it. What I say about the X-ray, what you say about the X-ray. So that object becomes more and more aware, just like a person.
You're listening to The AI Optimist with Declan Dunn.
Wow, the Aware AI X-ray. Sounds like something ChatGPT would hallucinate. Well, in part 2 of our interview with Omadeus CEO, Masoud Alabash, we take a look at how an X-ray can actually be intelligent and how this might impact healthcare. And before you jump to conclusions that this sounds like really crazy, anything can be an object, because object messaging is not new. Just like people send and receive emails, objects in computer systems send, receive, and process messages to execute functions. But now with intelligent objects, sometimes called smart objects, all these tools have built-in intelligence. And it's not just healthcare. For example, sure, you could have an aware X-ray that has an idea of the stakeholders, who's involved, what's important, what are the regulations, when does it need to notify people, instead of relying on people to have to move the object's meaning and messages along. It's also impacting agriculture, where they have soil sensors depicting how much water to put in, or robotic harvesters. Even back to healthcare, there's patient monitoring. What you're looking at is a whole world that Masoud says should operate like a symphony, like an orchestra, playing in harmony, playing together with each player doing their role, and AI lifting the role of the terrible drudgery chores of men moving stuff around and making us more efficient. Take a listen. This is really fun. The Aware AI X-ray. If intelligent objects will make healthcare efficient, imagine what they can do for you.
So imagine in your company, however big it is, imagine you have this magical person that knows everybody, who knows everything everybody does, and knows you, and knows exactly what you do, and is just sitting there for you to ask or do your thing, and just hand it the thing, and it'll go give it to whoever it needs to do at the right time, at the right place. And whenever they have things for you at the right time, right place, that's relevant to you. They don't. It just picks it up and bring it to you, and without them asking. So it really becomes your personal butler in a way for everybody in the company, and it knows everybody's jobs, and it really creates this harmonious symphony inside the organization where the information flow moves around without, in time, in tempo, without any collisions, without anything sitting there somewhere and hiding. So it creates that. And in fact, I think I mentioned that when you do connect nodes together, when you connect them and when you optimize information flow between them. This is how nature creates intelligence. Let's say we're in a doctor's office and I'm a technician who takes an x-ray. So I take your x-ray, a chest x-ray, and then I create that object inside the computer, and I say, well, this is an x-ray of, James, and this is his age, and this is chest x-ray. So this is tradition. This is what we do already. So this is the structured information that gets attached to that x-ray. Now we can build logic and traditional logic as to give this x-ray programming to help it to navigate through workflow. But we also give it a large language model. We attach a large language model to this object. Now, this large language model can read all this structured data and can also interact with me as a human using natural language. Because now I made that x-ray capable of interacting with me as a human using natural language. But I also give that x-ray a bunch of different diary books. I give it a black diary so it can keep track of the dialogues between me and itself and the doctor and the nurse, because that black book is special. It just puts all the information that's related for us. And I give it a green book because it wants to keep track of the dialogue between the doctor, the nurse, and the patient. Because I'm the x-ray person, I don't need to see that. So basically the object becomes aware of what it is, because now it knows it's an x-ray, because it has a large language model, it has AI. It gains self-awareness as to what it is. And it's programmed to know how to navigate the workflow. For example, it's programmed to know that as soon as it's taken, what you should do, you should go to this address over the internet, and here's your authentication, here's your passcode, and you go to over the internet to Mayo Clinic's database, and they've got this other model that is designed to read x-rays of your type, feed yourself to it, that produces a report in natural language. Take the report, read it, and understand it, and if you've got any major issues, immediately report to Dr. Smith or whoever your primary doctor is. Okay, so you can make that today. We can actually create that today, right? Everything that I explained. A combination of traditional programming and adding the LLM, using this new architecture that we are proposing. Identify the object, create these channels, different channels that I call the diary books, for different classes of stakeholders to maintain the information about itself. And that information includes the dialogue with each other. So if I, as the technician, I'm talking to you, the doctor, about the x-ray is present, it's listening, and it's actually recording all of our dialogue in its black book. I say something in the black book, you respond to me in the black book, and every time I put something in the black book, the x-ray shows up in your inbox and says, hey, here's what Masoud said. Here, it opens up the book and you can read it. Yeah. And then you say something in it. So that's how the x-ray keeps track of us as stakeholders, and it bounces around, and it's intelligent. It knows that, okay, now I got to go and hit myself against this model that reads x-rays in Mayo Clinic, and I just read it and go, oh God, I'm cancerous. I got to run over and show myself to Dr. Smith. X-ray, and this is what we call object messaging. Our model is called object messaging and intelligent objects. Right. And so the object itself is intelligent, and it carries all the information about itself, and it presents itself during the process of moving around in the workflow, interacting with other objects and interacting with other humans. Depending on what happens, it records those events in natural language in the right channel, and it presents itself to the right stakeholder at the right time. Critical key points, the things that humans are not good at. Delivering information to the right person at the right time. Okay, because that right time has something to do with the tempo of the workflow. That's the heartbeat of the organization, that the whole machine needs to be moving with that tempo. And each object has its own heartbeat in a sense, right? It's moving around. So the X-ray as a component belongs to, as a small object, belongs to a whole series of things. It belongs to a visit, that's a super component that contains its sister, which is a blood test that was ordered by the doctor, right? Or some other exam. And the actual, primary exam, the taking of your blood pressure and your vitals that the nurse did initially, that itself is a super component. Each one of those, the measurement of your heartbeat, the measurement of your temperature is actually an intelligent object. And together they create the vital supercomponent. And that supercomponent vital is itself an object. And it has an awareness about itself. So at one point, the doctor, and they all have the LLM that they can have interact with the stakeholders, humans, but they can also interact with each other using natural language. So, and if you think about this system that is composed of lots of intelligent objects, organized in these hierarchical fashions in a way, but around the workflow as they're moving around and interacting with humans. So it's the object that knows that, God, I got to run over and show myself to Masood and say, hey, look, I'm cancerous. So it shows up you're the primary doctor, says, look, I just got this report and here are the highlights of what you need to look at. And by the way, here's the report because you didn't put it in some file folder and somebody emailed it to you. I'm carrying it. I'm the x-ray. This is information about me. I'm holding it. And I can show you whatever you want. By the way, I can show you the whole report, or you can just ask me questions because I read the report. And I can tell you the important stuff. And you got to look here, look here, look here, and look here. And by the way, because you're the primary doctor, I have identified a specialist who lives in South Africa and is on the system. And I negotiated with this appointment object. In 2 minutes, we're going to have a conference call, and I'm going to connect you guys. And boom, here, we're connecting you. Now you guys are having a conference call just like this that you and I are doing. And guess what? The x-ray is sitting there listening. Why? Because it can understand the language. And you guys can talk about it. And it also read the report. It can even have an opinion and say, well, I understand, Dr. Smith, you're saying this, but the model at Mayo Clinic said this about me. So I'd like to highlight that area. So you have 3 doctors all having conversations here. So the x-ray itself is also a stakeholder in this. Because it has intelligence about itself. And all this information, the dialogue, the video is all captured at the end. You don't need to save it in some file folder. Don't worry about it. The x-ray will hold that too. And in fact, I've read it and I've known everything about it. And 2 months later, when I show up in your inbox for some other reason, if you don't recognize me, you ask me, say, well, what are you doing in my inbox? And so you don't remember me? You talked to Dr. Smith about me, and this is what you said. Would you like to see that 10 seconds of the video? Here it is. This is what you said. And this is what he said. Oh, really? So you can interact with it like an intelligent object or intelligent entity and query it. And so, and that object itself knows that it's part of a whole visit and it belongs to this patient. And so when you decide to talk to the patient, says, okay, well, I'm going to, by the way, I've also negotiated and sent an urgent appointment request with my patient for which I belong to that patient. So you can have a dialogue with Mrs. Smith about me. But remember, these are the new HIPAA rules that were passed. And these are the things that you need. These are the guidelines that you need to follow. I just read them. They were published 5 minutes ago, but I just read them. So here I could tell you what to say, what not to say, right? So just imagine that so all the information about these objects end up at the right place, right time. So we don't need to figure out where to organize this stuff, which file folder to put them, who to send them to. That is what we call object messaging, an intelligent object. And it's an architecture that we're proposing that merges the new LLM, this form of AI, with traditional software systems, but with a new architecture altogether.
Wow, so many layers to that too. But it's interesting because one of the things I thought, just using your X-ray analogy, the X-ray old ways is an output that sits around and somebody's memory has to be able to process it and hand it around, maybe the facilitator, maybe the doctor, but making the actual data, the actual output, intelligent of its place in our integrated system platform, that it knows, and it knows to look and communicate, and it's actually being an active participant. so it's not like data is so considered past, right? And
very well put. Very well put. It's no longer data. The X-ray is an intelligent entity, and you can think of the notion of an X-ray. The actual film is just data, is one of its attributes. There is an intelligent, a virtual object that's intelligent that knows that this film is just part of me, but I'm an X-ray. So you've given some form of awareness there that is a combination of large language model and traditional algorithms along the structured data that you're an X-ray, you're a chest X-ray, you belong to a 65-year-old Susie Q. And actually this is, by the way, this is her blood test, So, and in fact, the combination of all these components and super components can be controlled by a higher level brain. So if I go back to the example of the mobile phone, right? So if you imagine, and this is actually a new paper I'm writing about the AI-based operating systems, such that there's an LLM in front. I mean, right now you have Siri and Google Talk or whatever they call it. And most people who've used it, I don't know of anyone who uses it because they're stupid. They're dumb because they don't really have access to information because they're pre-programmed with some hard-coded stuff. They know some things about the weather. They've been loaded up with some, but they don't know anything about my Bank of America app. They can't access that. Right. They can't go in there and click in there and figure out how to navigate in there and look up my balance and see how much I've budgeted for my lunch today. Or they can't access my diet program or my fasting program. It can't access any of the other programs. It's not connected to any of those. And even if it was connected, it couldn't really communicate with the current model. But imagine every single app on this device is written using object messaging and intelligent objects, such that the actual app, you can interact with it using natural language. And then you put a higher level brain on top of this, and the user just talks to the big brain and talks to the computer, and that big brain decides and deciphers, saying for that, he's hungry. Okay, let me first talk to the diet program and get what his situation is there. Okay, he had fish yesterday. Okay, the diet program says he should have chicken. Okay, I'll take that. Well, let me talk now to can we afford this? What can I get him? Let me talk to the Bank of America app, see what we got there as a budget, right? Like, okay, so bang, here it is. What do we got in our budget? This is what you've got for lunch today, $15. Okay, now let me see what I can get with $15 chicken. Oh, here's his location. So this is all AI stuff, right? Okay, I found 3 different things. Let me display that on his screen. Here it is, right? Okay, and then Masoud says, I don't like any of this stuff. Give me something fancier. Right. Says, well, we can't afford anything fancier. It's already got all the information, you see? So this kind of architecture that I'm describing can make possible what you saw in that movie, Her. ChatGPT type of AI, these large language models, I don't care how many more parameters you feed them. I don't care how much more tuning you do. I don't care how much more computing you throw at them. Version 5.0, 6.0, 7.0, with this current architecture, they're not going to be able to give you what I described. And in fact, my argument is, why go there? We can actually show already an existing architecture that can deliver this. And by the way, the output of these LLMs are not all that reliable, because they call that hallucination. And then so you're aware of that. And so the part that's reliable is the processing of the natural language. Because even when it hallucinates, which is euphemistically referred to as hallucination, the Google people call it that. I call it confident bullshitting. It's quite confident. And I mean, if you've ever seen it, it's amazing. And I've known quite a number of insurance salespeople who use the same. They hallucinate.
The 2-step,
yeah. So that's not really reliable. And so I tell some of my friend engineers, like, would you allow ChatGPT's output to fly your plane or drive your car? No. because it hallucinates, right? So when you build a system, engineers like to have a reliability. When we build a plane that's going to cross the Atlantic, we put two engines on it, both for load balancing. They're both working, and also what we call fault tolerance.
Right.
If one breaks down, the other one still can get you home, right? So, and these are critical things we're doing and operations we're doing in saving patients and building systems, managing nuclear stations. Most of the stuff we do at work, they're critical. They're mission critical, they refer to as, and you can't have the output of ChatGPT or the output of these systems drive that. So you need a combination of deterministic logic, the traditional enterprise software, with a new approach, a new architecture that we've proposed, I refer to in my paper as object messaging and intelligent object that I described. And you take the natural language capabilities of AI and combine them in this way, and voila, you have a beautiful system that is intelligent, and you can build that today. And when you're thinking of programming, the intelligence needs to become distributed, and this is how the object messaging actually really works, that every single real or virtual object in the system is intelligent. It has self-awareness. It is aware of itself. It's aware of its environment. It's aware of its stakeholders. It knows, oh, you're the patient. I'm the X-ray. You're the technician who took me. You're the doctor, the primary doctor. It knows all these people. And it knows I'm a chest X-ray. And it knows that, okay, I was programmed when I was taken because somebody wrote the program. So when I'm taken, I'm going to read this program because this is a code. When I'm taken, I'm supposed to take this authentication token that was given to me. I'm going to go through the secure path over the internet and find this X-ray reading model that's been trained to read chest X-rays. And I'm going to feed myself to this model, and it's going to produce a report in natural language, in English for me. And I'll wait. It processed me, and it produced that report. Oh, I'm going to read that report because I have an LLM. I'm going to read it. Oh, shoot, I'm cancerous. What do I got to do? I'm programmed. I know I got to go show myself to my primary doctor. This is part of the workflow that's already programmed by the programmers when they designed this system with this new architecture, object messaging and intelligent object, that it just follows and goes in front of the doctor, says, hey, in the inbox, urgent, top of your inbox, I'm the X-ray object. Here it is. Open up, the doctor opens up, say, hey, give me a summary. Oh, here's the patient. So because that intelligence of that X-ray is also connected to the patient and the patient records, and the patient itself is an intelligent super object, right? Has an LLM, it has access to all these smaller objects. So the communication can happen in a very distributive mode, but it also has a hierarchy where you can actually have a brain for your system that, just like our brains, right, that communicate with the organs and move your body, and then I can use natural language to interface with you, with your brain, and you use natural language to interface with my brain. And if you have something request to have from my hand, you ask me to hand you this glass, and my hand, it communicates to my brain communicates to all the right objects, and the right objects also have intelligence, and they pick up the glass and they hand it to you, right? And it's traffic controlled by my supercomputer in the brain. That's a similar architecture in creating an accounting system, an electronic medical record. This is the architecture that we use to create our project management system, which is really distributive intelligence, and and you can actually talk to it using natural language.
The AI Optimist.
My name's Declan, and I'm done. See you next time.